Hey guys, welcome back. Today let's take a look at sine and cosine. Previously we've just graphed them without changing anything, and today let's change their period and their amplitudes. So just a quick summary. If you don't want the summary, skip ahead to the questions, but just a quick summary, right? When we're changing our amplitude, if the number is bigger, and usually most textbooks call it A, if the number is bigger than 1, right, there's you can consider a hidden 1 in there, it's going to stretch your graph, right? It's going to make it more steep, bigger maxes and bigger mins. So here's an example of 2, just to kind of visually summarize. Here's an example of a number smaller than 1, right? It's going to kind of smush that, stretch that out. Again, the period's 2 pi. We're not changing anything. It's the original sine and cosine period before you change anything. And a equation that'll be more helpful later. Here it's a little easier to see that, yeah, my max is 2, my min is 2, my amplitude's 2, but max minus min divided by 2 is going to help us once we start changing and shifting the graph even more. And one other thing to remember is that if you have a negative in front of this A value, again, amplitude is always, it's always positive. It's an absolute value, right? What is your, how far from that midline is it? Well, it's 2. It doesn't matter if it's up or down, it's still 2. But if you have a negative, what happens? Well, that reflects it over the axis. So these are things that you want to remember from class. And additionally, in terms of playing with our period, right, we said our original period is 2 pi. Oh, sorry. Ambulance going by. Over here, if we change the value, and maybe I think it's helpful for students to write parentheses here, just to remember it's the sine of 2x altogether, right? Don't let the 2 fly out. What happens? Well, instead of 2 pi, where do you complete that cycle, right? That's what a period is, one complete cycle. Well, now I'm going from 0, right, that intersection point, up, down, and back, it's pi, right? Multiplying by 2 halves my period. So, and the equation you want to remember, how are these related? This value that we usually call b and the actual period, well, the period is going to be 2 pi, that original, divided by that value b. And again, if we put a number smaller than 0, and again, I like parentheses here, what happens? Well, again, period is 2 pi to start. Well, I couldn't even fit the whole period on, one whole period because it stretched it, right? It's almost it is a factor of 2. Instead of 2 pi, I only got half of it in at 2 pi. So the period here is 4 pi. So these are things that you want to keep in mind when we're graphing, right? There it is. Doesn't matter if it's sine or cosine. We treat them the same. So let's start. All right, here's a graph. And let's find its amplitudes, period, and let's write the equation. All right, so amplitude. How high or low above the midline does it go? Well, this is 2.5, right? And so this is negative 2.5. So my amplitude is 2.5. Good. And again, could we use our formula? Sure. My max is 2.5. My min value is negative 2.5. And if I divide by 2, well, what do I get? 5 over 2. Yep, same thing, 2.5. How about period? Did that change? Well, I went from 0, right, at your origin. Let's see, we go up, down, and we're back to repeating a full cycle at what? 2 pi over 3, or 2/3 pi. So your period is 2/3 pi. Or I guess I usually write it as 2 pi over 3, so I don't lose my pi. Either way, it's the same. Let's put in an equation. For now, for our first couple practice, before we start any other changes other than amplitude and period, if it's crossing the origin, that's sine. So, and you know why, it's not magic, it's what happens at 0. Well, at 0, your sine value, right, the y value is 1 on your unit circle. So let's fill it in. Y equals, and maybe write the general form first, y equals a times the sine of bx. Okay, a we said, amplitude is 2.5, so y equals 2.5 times the sine. Well, what's b? B is not the period. We can't plug that in. Let's use that equation that we talked about before, right? Your period is going to equal the original 2 pi over b. Well, we found out the p part, the period. So 2 pi over 3 equals the other side of the equation here, 2 pi over b. Well, pretty quickly, you could see that 3 is b. If you didn't see that, you could always go and cross multiply if you want. B times 2 pi equals 3 times 2 pi, which is 6 pi. Right? Divide both sides by 2 pi. And what do you get? Well, those cancel. B equals, your pi's cancel. 6 over 2 is 3. B is 3. So we can plug that on in, right? 3 times your variable, x. Perfect. Let's try another, right? And you try first, pause it, and see if you get the same. Well, amplitude in this one, well, from my midline, I'm going up. What's this? This is a half. And what's this? This is negative a half. Oops, negative 1/2. So my amplitude, up a half, down a half, is a half. Again, if you're not sure, max minus min divided by 2. How about your period? All right. I go from, I like max to max is usually the easiest way, I think, or min to min. You could go from, this intersection to this intersection, but a little easier max to max visually. So I start at a max, I go down to the min, back to the max. What's that period? 4 pi. So my period is 4 pi. And let's put it all together. Is this going to be sine or cosine? Well, I'm not on the origin, so it's not going to be cosine. Sorry, it's not going to be sine like our last one. It's going to be cosine. So my general form, y equals a cosine bx, and I like this in parentheses so we don't make any mistakes. A is a half, so y equals 1/2 cosine. What's b? Let's put that back in our original formula of pi equals 2 pi over b. Sorry, period equals 2 pi over b. So we said in this case, our period is 4 pi, and I get 2 pi over b. If you want, you could cross multiply or just multiply by b, right? Get this out of the denominator. 4 pi times b, right? I multiplied by b on both sides if you want to see my work here, times b equals 2 pi. Get b alone here, so divide by 4 pi, divide by 4 pi. Sorry, that was a little sloppy. B equals, my pi's cancel, 2 over 4 is a half. So b is a half. So y equals 1/2 cosine, 1/2 times x. All right, let's go the other way now. I'm going to give you the equation, you graph it. All right, so a couple things. I like to summarize first so I can check once I start plotting to see, am I doing this right? So if this is A, right, so your amplitude is 3, and my period, do you see anything here? No, so it's my original 2 pi for cosine and sine. So this better show up when I start plotting. You might know how to graph it right away, but if not, let's plug in a few numbers and see what we get. So we get y equals 3 times the cosine. Let's start at 0. If I put in 0, well, what do I get? What's the cosine of 0? Again, think about your unit circle here. Cosine of 0, my x value at 0 is 1. So I have y equals 3 times cosine of 0 is 1, 3. All right, so I'm starting at 3. Cosine's going to start on your max. It's a nice kind of quick cheat to think about. Let's plug in something else. Let's plug in pi over 2. So y equals 3 times the cosine of pi over 2. Well, the cosine of pi over 2, that's 0 up there. So all of this is going to go to 0, right? If this is 0, 3 times 0 is 0. So at pi over 2, I'm at 0. Let's put in pi. Y equals 3 times the cosine of pi. Well, the cosine of pi, I'm over here, that's negative 1. So what's y equals 3 times negative 1? Well, that's just y equals negative 3. So over here, I'm at negative 3. If I put in 3 pi over 2, y equals 3 times the cosine of 3 pi over 2. Well, where am I now? Down here. Again, that's 0, right? So this is 0. 3 times 0 is 0. I'm back at 0. And if I finish up with 2 pi, y equals the cosine of 2 pi. Well, at 2 pi, I'm back over here. We said that was 1 before. I'm back at 3. So at 2 pi, I'm at 3. And maybe let's go in the negative direction just to make sure we see our pattern. Y equals 3 times the cosine of negative pi over 2. And you're going to quickly see these start to repeat, right? Now I'm back down here, right, where I already said was 0. Right? So when I go back this way, I'm at 0. And this should happen, right? These are periodic functions. If this is a whole complete cycle, because I went from max to max, right? And don't have your arrow go off that way. It doesn't go up. It starts to go down and repeat. I should get this mirror image over here, right? And if I put in negative pi, well, what happens last time at negative pi or at pi? Well, that was over here, right? At pi, either pi or negative pi, it's the same. I get negative 3. And is this right? Yeah, it follows our pattern. So I'm going to fill in my other pieces because I know what they are, because it's just going to follow the pattern. And I get this nice cosine curve. Oops. Well, it was nice before I did that. Okay. And again, double check. Does the amplitude look like it's 3? Yeah. Up 3, down 3. That's that. Does it repeat after 2 pi? Is it a full cycle? Yeah, perfect. I did this right. Woohoo. All right. Try the next one. Give this a shot. Lots of stuff's going on in this one. And then check it with mine. All right, so let's take away some of the pieces we know. I know that my amplitude is going to be 2. I know that it's going to be reflected, right, over the x-axis, reflected over x-axis, because that's what that negative does. And if my b is 2, what's my period then? Well, we said the formula is period is 2 pi over b. Let's throw that in. Let's throw the 2 in. So period equals 2 pi over 2. Your period is pi. So sine got condensed, so it's going to be squishier. That's a horrible way to describe it, but your period was shortened, right? So now it's going to do a full cycle in a time of pi. All right, let's plug in some values and make sure we'll double check it with what we know from just the equation. So maybe let's come over here and do some scratch work. Y equals -2 sine of 2 times, let's start at 0. If I plug in a 0, well, let's look at our unit circle here. At 2 times 0, I'm at 0. Sine of 0 is 0. All right, -2 times 0 is 0, right? Sine, as long as we're only changing amplitude and period, is always going to start at 0. All right, we got 1 point. Let's do pi over 2. Y equals -2 sine times 2 times pi over 2. Those cancel. I'm going to rewrite so I don't lose any of my information or get too sloppy. Sine of pi. All right, sine of pi, I'm over here. What's my y value there? Also 0. -2 times 0, I'm at 0. Okay. How about pi? Y equals -2 times the sine of, 2 times pi. Right, I'm putting in x for pi. Don't forget to do your times 2 each time. All right, sine of 2 pi. Well, 1 pi, 2 pi. I'm back to 0. Interesting. And if you keep putting these in, you're going to keep getting 0. Does it matter if you put a negative in? Let's see. Let's double check. The answer is no. 2 times negative pi over 2. Well, the 2's cancel. I get sine of negative pi. What's the sine of negative pi? Oh, gosh. 0, right? So this is not a very curvy looking. We're going to have to put in something in between. So let's give it a shot. Let's put in pi over 4. Very sloppy pi over 4. All right, let's scratch that out. Y equals -2 times the sine of 2 times, what did we just say? Pi over 4. Let's do some simplifying. Y equals -2 sine of, the 2 cancels, and I'm left with the 2 here. So I'm really looking at the sine of pi over 2. Okay, where's the sine of pi over 2? That's up here. It's 1. Right? The sine of pi over 2 is 1. So y equals -2 times 1. Y equals -2. All right, so at pi over 4, I'm down to -2. All right, at least I have something that's not on this origin here. Let's put in 3 pi over 4. All right, that's what's in between here. So what is the sine of, oops, sorry, that's not, oh no, I'm right, right, half, yeah, another half. Right, so I'm putting in this. I'm not on my unit circle yet. Let's just input this into my function. I'm kind of jumping ahead. So -2 times the sine of 2, right? 2 times 3 pi over 4. Right, when you have these changes to b, make sure you don't make the mistake like I almost just did and jump to over here. Right, first, before we take our sine value, we need to evaluate what's in our parentheses, right? The sine of after you multiply by 2. So let's multiply this by 2 and simplify. Well, 2 cancels, and I have 2 left in the denominator. Let's rewrite it again so we're not sloppy or make any mistakes. So what's left? 3 pi in the top and the 2 in the denominator. All right, now let's actually reference our unit circle here. Sine of 3 pi over 2. So where's 3 pi over 2? Pi over 2 pi, 3 pi over 2. What's down there? That's the sine of 3 pi over 2 is -1. So let's write that. Y equals -2 times -1. I get y equals 2. Okay, so at 3 pi over 4, I'm at 2. And here you can start to see this is starting to be our sine curve. If you want, I suggest, try put in some more, right? Go another quarter. Put in 5 pi over 4. Go another quarter after that. Put in sine pi over 4. Sorry, not sine pi. Put in 7 pi over 4 and see what you get. You're going to get the same pattern. Right, your sine curve is going to come down. Whoops, let's curve it a little back up. right? And we've repeated, right? I've done a full cycle here. I'm going to be back down at 2, back up, continue, right? And it's going to go the same way here, right? Put in negative pi over 4, right? If we put in negative, if we look, even if we look right here, if I put a negative here, I'm going to have a negative pi over 2. Well, what happens when I'm at negative pi over 2? Negative pi over 2, I'm going to have negative 1. Well, negative 1 times negative 2, I'm at 2, right? So you plug in as many as you need to convince yourself that this pattern is going to repeat forever and ever. And so I get this kind of condensed period, and always double check with our information at the end, right? Is this right? Is A 2? Yeah, I go up and down 2 for my midline. Is it reflected over the x-axis? Yeah, generally sine goes up first, right? And so what happened here? It's going down first. And is your period pi? Yes, it repeated after pi. All right, one last one, and we'll call it a day. Give it a shot, double check mine. All right, let's, what's A? A is 3, okay? This is my B value, right? And maybe I should put a double parentheses here, right? I'm not going to take the cosine of anything until I multiply by pi over 4, right? I guess I could have used the computer a little better to kind of make this look more like this, right? Pi over 4 times x, right? Same thing. There's implied parentheses when I see cosine, so remember that. Anywho, all right, what's my period? This is my B value, so let's write that out. Period equals 2 pi over B. Let's fill it in. Period equals 2 pi over, I'm saying my B is pi over 4. All right, well, that certainly looks yucky. Let's multiply by its reciprocal, so 2 pi times 4 over pi, and maybe put a 1 over here to kind of see those a little more clear. Cancel our pi's. What's 2 times 4? Your period is going to be 8. 2 times 4 is 8. All right, well, if my period's 8, maybe before we even start, let's kind of change our numbers here. Instead of trying to find 8 on, well, 2 pi is about what? 2 pi times 3.14 is about 6. You could do that and say 8 somewhere over here, like past 6, but let's just change our axis to make it look a little better. Maybe we'll go up by 2. So 2, 4, 6, 8. Who do we appreciate? Sorry, so corny. -2, -4, -6, -8. All right, that's a little better. Again, could you use this axis? Sure, but awkward. All right, so we better see these at the end. Let's plug in some values. Y equals 3 times the cosine, start at 0, of pi over 4 times 0. Well, we know cosine of our 0 times anything is 0. What's the cosine of 0? 1, right? 1 in our unit circle. My x value is 1. Y equals 3 times 1. All right, let's plot that, 3. Let's go a little further. Let's go to 2. Y equals 3 times the cosine of pi over 4 times 2. All right, well, you can consider it 2 over 1, right? A 2 would cancel. I'd left with 2 over here. Let's write out that very sloppy thing here. So I have pi over 2. So what's the cosine of pi over 2? Well, if I'm up at pi over 2, that's 0, right? So I have 3 times 0 is 0. At 2, we're at 0. Let's plug in 4. Y equals 3 times the cosine of pi over 4 times 4. All right, well, this is 4 over 1. Your 4's canceled. Let's rewrite. Y equals 3 times the cosine of pi. All right, we're at cosine of pi over here. That's -1. So y equals 3 times -1. So now we're at -3. All right, so at 4, I'm at -3. Let's put on in a 6. Y equals 3 times the cosine of pi over 4 times 6. Let's see, we can cancel this over 1 if you want to visually see. 2 goes into 4 twice, right? Canceling that. 2 goes into 6 3 times. Let's rewrite this very sloppy looking thing here. Cosine of 3 pi in the numerator. 2 times 1, 2 in the denominator. Well, what's the cosine of 3 pi over 2? Well, 3 pi over 2 down here, back to 0, right? So this is all gone. So at 6, I'm at 0. Oh, that kind of makes sense. Kind of looks like things that we've seen before. And lastly, let's put in 8, even though I bet you can guess where we're going to be. Cosine of pi over 4 times 8. You can say 8 over 1. Well, 4 goes into 4 once. 4 goes into 8 twice. Let's rewrite what's left. 3 times the cosine of 2 times pi. Right? Only 1 in your denominator. Well, I'm back at 2 pi. I have 1. Right? Cosine of 2 pi is 1. Y equals 3 times 1, which is 3. Right? So at 8, we're at 3. And we've completed a whole rotation. And again, do you want to check do you want to put more values in to confirm that this is what it looks like and it's going to go back down? Go for it, right? Put in a 2. You're going to get that same 0 as an output. So to fill this in, cosine looks something like this, right? And don't let your arrow go up. It doesn't go up. It comes back down, right? And I'm coming down here. At 4, we're going to be back at 3, back at 0, back at 3, then negative 3 down here, back at negative 3. Right, so plug in as many values till you can see the pattern. And double check. Did we say in the beginning A should look like it's 3? Yes, the amplitude, up 3, down 3 from that midline. Period. We said it should be 8. Does it repeat after a distance of 8? Yeah, that's one full cycle. And you can look max to max or min to min, however you want to look. All right, so take your time doing these, get comfortable, and hope this helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples or if you want another topic to be covered.